Hello everyone, I'm Akash Tejwani and today we'll go through the experimental setup of reaction of metals with acids. To understand the experimental setup, we need to first know how do metals react with acids. So at the base of it is metals, or rather I should say, most of the metals react with acids to give salt and hydrogen gas. Acids contain, or the basic definition of as an acid is that it donates H plus ions. And the same H plus ions in the solution acquire electrons and therefore through it become hydrogen gas. That same hydrogen gas cannot be kept inside the medium, so it rises up, and that hydrogen gas can be collected and further stirred on. We can test hydrogen gas by one main method. That method is hydrogen is a combustible gas, and when we take it near a burning source, it burns very brightly with a pop sound. So, to do this experiment, we have two different setups. A simple setup that is in front of you, and another setup which is the more safer version of the same experiment. The setup in front of you is we have taken a conical flask and a balloon. Inside the balloon, we have inserted magnesium pieces. Generally, magnesium metal, we get it in the form of ribbon. That same, we can cut it into smaller pieces with the help of a scissor. It is not a very tough metal as such. We can cut it with the help of a scissor, or we can even grind it. But cutting it with the help of a scissor is better version. And after cutting it, we have inserted it into the balloon, just like sparkles are inserted in the birthday balloons. That same balloon is now fitted onto the mouth of the conical flask here. Once the experiment, once this has been done, we can start with the experiment. The HCl that we have taken need not be a concentrated one. We can take diluted version of HCl too. So once we have framed the setup or we have properly set up the instruments, we can start with the experiment. It is not very difficult. Just lifting up the balloon would push the metal pieces down into the solution. Once the pieces are down into the solution, what would happen is the metal would react with the acid and slowly, depending upon the concentration of the acid, hydrogen gas would start forming. That same hydrogen gas that has started to form cannot stay into the medium. It rises up. Hydrogen is not highly soluble in water, so it starts rising up. And once it rises up, it starts filling up into the balloon. We wait for the balloon to expand. Once the balloon has expanded and the bubbles have stopped forming, we can detach the balloon from here, take it a bit away from the laboratory, and in a safe condition, we can take it, or we can take a matchstick or candle and ignite the balloon. The balloon will burst with a large pop sound. Now, this experiment is well and good. It explains whatever is required within the reaction, but it has certain safety issues. One of the safety issue is that large amount of hydrogen gas is getting collected inside the balloon, and that same hydrogen gas, when if not handled properly, it would cause serious injuries to the person. So rather than this setup, we go for a better setup which is safer compared to this. This is the second method in which we can understand the reaction between an acid and a metal. Now, the first method had its own usefulnesses and drawbacks, but comparatively, second method, this particular method is more safer and gives us a better result compared to the first method. So in this method, what we do is we take a test tube. In the test tube, we first take the metal pieces. Here, in this particular case, we have taken zinc granules, that is, small pieces of zinc. Then we attach a rubber cork so that during the reaction, whatever gases are formed will not go out. This rubber cork is going to stop all the gases, or it is going to force all the gases to remain inside. In the rubber cork, we make a hole, and first we insert or we add whatever acid is required. We do not add the acid at the beginning itself, because the reaction there and itself it will start, and it will we will lose a large amount of hydrogen gas. So what we do is first we add the metal pieces, attach the rubber cork, and this rubber cork is drilled with a hole. Then we add the acid from the top, and after that we add the acid with the help of a dropper. And then after that, what we do is we insert a bent tube, or we also call it as a delivery tube. This delivery tube is inserted into a soap solution, or a beaker containing soap solution. Why that is done, we'll come to it afterwards. Now, in this test tube, what is going to happen is the pieces of zinc start reacting with, particularly in this case, we have added dilute sulfuric acid. They start reacting with dilute sulfuric acid, and once they react, they start forming hydrogen gas bubbles. Slowly, the bubbles rise up, just like in the earlier experiment, the bubbles are going to rise up because hydrogen is very, very minutely soluble in water, and all acids are prepared in the base, or they are prepared in water. So hydrogen won't stay in the medium, it rises up. Once it rises up, it does not have any opening here to go out, so it has to forcibly enter through the delivery tube. It goes up and then comes down into the soap solution. Once it has come down into the soap solution, what happens is the bubbles come up here, and since hydrogen gas is very light, bubbles are formed very easily in the soap water. Bubbles start rising up. Now, once again, hydrogen gas is lighter than the air, or we can also frame it in different words as hydrogen gas is less dense compared to the air. So it rises up very quickly, and these rising bubbles can be tested with the help of a candle or with the help of a matchstick. The moment we bring a burning candle or matchstick in front of the bubble, what happens is the bubble pops, or it bursts with a pop sound. Also, it gives out huge amount of heat. Now, why do we say this setup is comparatively more safer, that is in comparison with the first experiment, is because the hydrogen gas that is coming out and the testing that we are doing here, it is being done to a very small extent. That is, every time the flame touches only each bubble. It is not that the bubbles are very close by. We can just test only a single bubble, and it will not lead to a chain reaction as such, or maximum two or three bubbles, surrounding bubbles, can pop at a time. And it is comparatively safer because a huge amount of hydrogen gas is not burning, or it is not bursting exactly at one single point, so it might lead to lesser amount of damages in case of an accident. So once again we can say this is a safer method to do that. Now, there is another reason why uh, we can add soap solution here that is prepared in water, is because if in place of dilute sulfuric acid we take HCl, it is not that different. HCl also will react with zinc. It will form zinc plus HCl will give us zinc chloride, plus along with that hydrogen gas. The difference is HCl is aqueous, or rather, actually, all acids are aqueous, but HCl in particular, the problem with it is actually HCl is gas. Hydrochloric acid is prepared when HCl is mixed with water, that is under pressure. So when we are adding HCl here, what happens is some amount of HCl also can move out of the water without reacting with the zinc and go up into the delivery tube. Now, once it has gone into the delivery tube has hydrogen gas as well as HCl gas. So, bubbles of HCl also can get formed, bubbles of hydrogen also can get formed. But when we add soap solution, only hydrogen bubbles are formed. Why? Is because HCl, when it comes in contact with water, once again it forms an acidic medium here itself. So it gets trapped inside the soap solution itself and it does not come out as a bubble. So whatever bubbles we get here, they will be purely hydrogen bubbles only. So in case of HCl, this is a separation technique. Thank you.